to determine the internal loadings that on the indicated section where you cut and then you see what are the internal loadings, right? Share the result on the left segment. So for instance, for A, okay, because we're going to do A, B, C and D, right? So for A, for instance, the beam is like this, right? Something like that, and then it is fixed over there. So this is the section. So when you cut, you have to take the left portion. Okay, so what you have to do is you cut and then you take just the left one. Alright, something like this. Right? So we'll start with A. For A, let's draw the cut section. Alright, so this is the fixed support, right? And then this is the surface, okay? And then of course you can find the symmetrical axis, right? So what kind of internal loadings that you have? Initially, not initially, at the other end, it's wrong, right? At this end, you have compression at top, sorry, tension at top 500 Newton, right? And then you have compression at bottom, which is 200 Newton. So what will be the resulting force? It is 300 Newton. Okay, that one for the axial load, the normal force. Okay, what else do you have? You guys realize that you have 200 Newton at the bottom and 300, is it 500 Newton at the top. So this will cause a bending moment, isn't it? About this centroid, about this, yeah, centroid, this center. Okay, so you will have bending moment M, right? And this bending moment is basically 200 Newton times 0.2, isn't it? 200 Newton times this 0.2 plus 500 Newton plus, because they are the same in the same direction, right? This direction. 500 Newton times 0.2, because we are finding moment about this centroid. Okay, so times 0.2. So your bending moment, internal bending moment about the centroid is 140 Newton meter. Right? So these two are the resultant internal loadings acting on this cross section. Alright? Of course, when we find the internal loadings, basically we find it at the centroid of the section. Okay? That one is for A. Next we go to B. Right? So B, you have check the question. You have the cylinder, right? The length is 2 meters from the end, the right end, to the section. And then you have the axial load of 100 Newton. You have the vertical load of 200 Newton. And you have this kind of transverse load at of 300 Newton. Okay? So if you cut, you take the left hand side, because the question asks you to find what is the resultant internal loadings at the right hand side. Okay, this is the fixed end. Of course it is longer, and then you cut and then you see what happened here. What do you have here? First, of course, okay, first let's draw this one first, this, so that you can look at the center. The center is here. Okay, the center of the circle, the circular section. Okay, the first one is the internal loads itself, like this 100 Newton. Alright, 100 Newton, same as your as what you have on the right hand side, right? The other end, 100 Newton. You have 300 Newton, isn't it? Okay, along this, and then you have this one, which is how much? 200 Newton. Alright, so these three are the loads. Okay, do you have anything else? These are the loads the forces. What else you have? You have the what? You have the bending moments, right? Why? Okay, 100 Newton won't have a bending moment. That's fine because it acts at the centroid, right? But what happened to this 200 Newton, and then you have this line. See? Oh, sorry. Let's go this one first. 300 Newton, and then you have the line, the original line, which is 300 Newton times how much? The line 2 meter, isn't it? So if you do this, so you have this moment which goes upwards, isn't it? When I draw a double arrow like this, it means moment, okay? This moment, okay, going upwards, 300 Newton times 0.2. No, 0.2 times 2 meters. Right? Is it 2 meters? Yes, 2 meters. So this 600 Newton meter. Okay. This one, okay, 300 Newton to 2 meter. Curl that one going up. Okay. So the curl direction is this, right? And then the direction of this is, of course, it is not really here. It is about the center, but I could not put everything here. Otherwise, you cannot see that. Okay. That's one. That one is for the internal bending moment due to this 300 Newton. How about this 200 Newton going down? So same, 200 Newton going down. You have this arm of 2 meters. You curl that one, so you have it along this 300 Newton. Which is that? Something like this. Okay. Okay, so this one is 200 Newton times 2, which is 400 Newton meter. It's okay. 300 Newton, 200 Newton, right? And then 2 meter, that one is the moment. Curl that one, this direction of curl, and the thumb gives you the direction of in XYZ coordinate, alright? So it is along 300 Newton over there. Okay, so this is your internal. So basically here what happened is originally you have these 3 loads and then you have 2 extra internal bending moments, alright, due to this and these loads which have arm, which is 2 meter arm about this section. Alright, so this one is for B. Next we go to C. By the way, these are just preliminary problems, okay? Basically, just want to, you have to master this before you go to the really combining the loads, right? Okay, then C is actually is like A, but now the loads are somewhat different, right? So now what you have is for C. Okay, this is the section. Okay, this is the section, right? Okay, at the other end, okay, it's long, right? We cut, we take the left hand side. So at this end, it is 200 Newton, right? And then at this end, it is 300 Newton compression. This is 200 Newton tension, alright? So what you have, the resultant, 300 Newton compression, 200 Newton tension. So at the center here, at the centroid, you have what? You have 100 Newton compression. Is it okay? 300 Newton compression plus 200 Newton tension, which is minus 100, isn't it? So it is 100 Newton compression. Okay, this one is for the axial load, internal axial load 100 Newton compression, right? At the centroid. So what else do you have? You have bending moment, okay? But in order to help you out, let's draw this, okay, the original load at the other end, right? Which is 200 Newton and 300 Newton, isn't it? Okay. So look here. what happen, what do these two loads do to this centroid in terms of the bending moment, alright? So can you see this? This 200 Newton, if we consider this distance and this distance for both of them, right? 200 Newton times this, okay, will give you this moment. Okay, this moment. Is it okay? Can you see that? 200 Newton times this distance, right? Will give you this moment curl, and then the thumb gives you that direction, alright? This 300 Newton, this way, take this arm, which is 0.2 here, curl that one, same, will give you this moment, isn't it? So for this moment, you have 200 times 0.2 plus 300 times 0.2. 200 times 0.2, okay, plus 300 times 0.2. Both have the same direction, okay? So now, here you have 500, sorry, not 5, is it 500? 200 times 0.2 plus 300 times 0.2, okay? So you have 100 Newton meter. Is it okay? That one, if you consider these two distances, you have another distances. Which one? Which are? This, isn't it? This and this. So what happened for this 200 Newton, okay, with this distance towards this centroid? So you have this moment going down. I mean, in the axis, xy axis, it goes down. So of course, the direction is like this, isn't it? And same goes to the 300 Newton. You consider this distance, so it will go down as well, isn't it? 300, arm curl going down. Okay, so this one basically you have 200 Newton times this, which is how much? 0.1, isn't it? 0.1 plus 300 times this, which is 0.1 as well. So here you have 200 times 0.1 plus 300 times 0.1. So you have 50 Newton meter. Okay. So the resultant loads, internal loads, 100 Newton compression at the centroid, and then this one at the centroid as well, 100 Newton meter. Okay. And then this one as well going down, okay, 50 Newton meter. So the internal bending moments, yes, of course they are quite tricky, but you need to be able to do that. Okay, we have done this actually. Okay, now we go to D, which is a bit tricky, so that's why I draw the original problem in diagram. So if you cut, you take the left hand side. What do you have? Let me enlarge it. Okay, so you have this. Okay, you have something like this, of course, this circular. Okay, fix over here, and you have this. Okay, along this axis. Okay, so first thing first, all these you have three loads, 500 Newton over there, okay, along this, 200 Newton going down, okay, and then 300 Newton going this way, right? So if you cut, again like before, you just have to substitute the same loads acting on the centroid of the circle, okay? So what do you have? You have this, probably the lines are not correct. Okay. So the obvious loads are this 500 Newton, isn't it? Same direction with this 200 Newton going down, isn't it? Going down, and 300 Newton going this way. Okay. So it should be, how should I draw it? Okay, it should be something like this. Okay, because something like x, y, and z. Okay, the other axis is not really following the direction. Okay, you have 300 Newton, 200 and 300. Okay, now we go to the tricky part, which are the bending moments, right? So you have to check for each load what kind of perpendicular distance or arm that they have with this section. Okay, let's check the first one. 200 Newton load. Okay, it has this arm, isn't it? 1 meter. This direction is same with the 300 Newton here, which is this. It's okay. Again, double arrow to show the direction of the thumb of the moment. Alright, so this is 200 Newton times 1. Okay. What else? Do you realize that actually for this 500 Newton, you have the same thing? Okay, 500 Newton times 2 goes that way. So you have another one here, which is 500 Newton times 2. Is it okay? Same direction. 200 Newton times 1, okay, this direction. 500 Newtons, 100 Newton times 2, which is the same direction. So this moment, this moment about this axis, it is contributed by these two moments. One is this force, 200 Newton with 1 meter length, and one is 500 Newton with 2 meter length. Right? So this one you have 1200 Newton meter bending moment. Right? Okay, what else do you have? You have this 500 Newton, this 300 Newton, okay, with what? The first one is with 1 meter here, right? Going down. Same with this 200 Newton load. The direction, I mean, okay? Going down. It is 300 times 1, which is 300 Newton meter. Is it okay? Okay? Okay, what else? So we already have 3 bending moments. 1, 2, 3. Of course, these two will constitute just one because they share the same direction. So one is here. What else do you think you have? This 300 Newton, for this one, you do previously you do this 300 Newton with this 1 meter, isn't it? That's why it goes down. Okay? How about 300 Newton with 2 meter? So you have this one going along 500 Newton loop, isn't it? This 300 Newton, 2 meter, right? This way. Okay, so it is to 300 times 2, which is 600 Newton meter. Okay, so you have actually here you have 4 bending moments. 1, 2, 3, and 4. Okay, 1, 2, okay, sorry, 2 this with this. 3 is this one, this with this, and the fourth one is this 300 Newton with 2 meter. Okay, so you need to check this direction. But of course, the resulting internal bending moments will be just 3 because this 200 Newton with 1 meter and 500 Newton with 2 meter, they act on the same direction. Alright, so these are the internal bending moments.